So to pursue the idea from the last chart, let's look at some examples of solving the kinematic equations with constant acceleration. In the top right hand corner I have the equations numbered as I numbered them before. Here are the missing quantities, so this is just basically a repeat. So the scenario we want to consider is a car brakes and decreases its rightward velocity from 30 meters per second to 20 meters per second over a distance of 20 meters. Assume constant acceleration. So 30 meters per second corresponds with v naught, initial velocity. 20 meters per second corresponds with v. 20 meters corresponds with x minus x naught. First question, what is the acceleration? Okay, so going over to the equations here, the missing quantity is t, so we're going to therefore use equation 3. Okay, equation 3, solving for a, is v squared minus v naught squared over 2 times the displacement. So that would come out as 20 meters per second the quantity squared minus 30 meters per second the quantity squared over 2 times 50 meters, 400 meters squared over second squared, minus 900 meters squared per second squared over 100 meters is minus 5 meters per second squared. Okay, please note the negative sign. And as a side note, it's really important to keep track of the signs when using these equations. If you don't, you'll go off the deep end. Number 2. What is t? In other words, what is the time required for this scenario to occur? So if we look back at the equations, a is missing. It was missing initially. We could have solved it differently if we'd taken a as a known quantity. But if we assume that a is missing, then what is t? So we're going to go over to this equation 4 right here, which if you solve for t is 2 times x minus x naught divided by v plus v naught. So that's 2 times 50 divided by 20 meters per second plus 30 meters per second. In other words, it's 100 meters divided by 50 meters per second, and that is 2 seconds. 2 seconds for this scenario to occur. Question 3. How long does it take to stop? Again, assuming that we have constant a. So in this situation, we have x minus x naught missing, so we'll use equation 1. And equation 1 solving for t gives you v minus v naught over a. So v now is 0 meters per second. V naught is 30 meters per second. So it's 0 meters per second minus 30 meters per second in the numerator. Denominator is minus 5 meters per second. So we have per second per second. So we have minus 30 meters per second over minus 5 meters per second squared. And that corresponds with 6 seconds. And again, notice how the signs are giving us a consistent answer. And again, be careful with the signs and also pay attention to the units. If you look at just the unit part of this answer here, it does correspond with seconds. Number 4, what is the stopping distance? Well, in this case, t is missing, so we are going to use equation 3. Equation 3 solving for the stopping distance displacement is v squared minus v naught squared over 2 times the acceleration, which is 0 meters per second the quantity squared minus 30 meters per second the quantity squared over 2 times minus 5 meters per second squared. That gives minus 900 meters squared per second squared over minus 10 meters per second squared. Again, the signs cancel out. The units give meters, and 900 divided by 10 is 90 meters. So that's the total stopping distance. Question 5. Assuming the same acceleration but using a different initial velocity v0, what is the braking time if the braking distance is 200 meters? Well, in this case, v0 is missing, so we are going to use equation 5. But equation 5 now, we can assume that v, the final velocity, is 0 meters per second. And so that makes this a very simple equation to solve. We don't have to use the full quadratic formula. We can just solve for t. And in that case, t is equal to 2 times the displacement divided by minus a. Please note there's a minus sign here. And so that's going to give me the square root of 400 meters over the negative of 5 meters per second. So that's 400 meters divided by 5 meters per second 8.94 seconds. Okay, some questions for you. Draw v of t versus t for the initial scenario. Question 2. What is v0 in scenario 5? Question 3. Draw a motion diagram for the initial problem. And question 4, take one of these scenarios that I have solved, problems that I have solved, and solve it another way. So the algorithm I have given you isn't one that you have to use. It's one that you can use.